In this video, I'm going to explain virtualization concepts in cloud computing. The second unit of cloud computing. Already we discussed in the first unit of cloud computing. There's a basics, there's introduction of cloud computing, so fundamental concepts of cloud computing. And then next topic, virtualization. In the second unit, we are going to discuss about the implementation level of virtualization structure and types, tools and mechanisms, and then virtualization of CPU, memory, and I/O devices, virtual clusters, and resource management, virtualization for data center automation. These are the topics we are going to discuss in the second unit. Okay, so I want to explain about introduction about virtualization. So the basics of virtualization. So virtualization is one of the important concepts in cloud computing based on infrastructure as a service. Virtualization is one of the very important. Okay, so virtualization technology is one of the fundamental components of cloud computing, especially in regard to infrastructure-based services. Okay, virtualization allows the creation of a secure, customizable, and isolated execution environment for running applications. So virtualization is a broad concept that refers to the creation of virtual version of something, whether hardware, software environment, or storage and networks. So this can be virtually we can use the cloud consumer can use the services from the cloud provider. Okay, so this is a basic components of virtualized environment. First one is a guest, another is a host, another is a virtualization layer. In that guest is nothing but a newly guest operating systems. So newly installed, newly created virtual machines called guest operating systems, and then ghost is nothing but already available in your ghost operating system. Okay, only available operating system is ghost. Another is a virtualization layer. It is in between guest and ghost. Okay, so just assume in my laptop have Windows 11. So I want to install guest operating system as Linux. So with the help of virtualization layer, I can create a virtual machine called Linux operating system. Okay, so here virtualization layer is nothing but a here virtualization layer is nothing but a hypervisor. So hypervisor is nothing but a it acts as intermediate between the guest and the host operating system. The host operating system and host is nothing but a original operating system machine, and then guest is nothing but a newly installed virtual machine operating system. Okay, so here hypervisor. Hypervisor have two types, one is a type 1 and type 2 hypervisor. So it's nothing but of the software that can interact with the host operating systems to allocate the resource to the guest operating systems. So in that two types of hypervisor, hypervisor 1 and hypervisor 2. This is a type 1 and type 2 hypervisor. And the type 1 hypervisor is nothing but the type 1 hypervisor is installed in the bare metal of the machines. Okay, this is a physical hardware. Okay, so it initially it takes some hardware components for the guest operating systems. That's a type 1 hypervisor. So here the layer is one is a layer 1 hardware, physical hardware, and the second one hypervisor, and the third one operating systems. Okay, so this is three layers only. In that type 2 hybrid something, but it is installed on the host operating systems. So physical hardware. After that we have ghost operating systems. After that we have hypervisor, which is in layer. In top we have guest operating systems. Okay, so this is virtualization concept. So we can create a virtually some things. So for either storage or network or any other applications. Okay, so either hardware or software environments. This will be used as virtual. Okay, so in virtualization of so another virtualization of CPU, memory, and I/O devices. So I want to explain something about virtualization of CPU, memory, and I/O devices. So in that first one hardware support for virtualization. Okay, here the all process in the hardware components will be we can use virtually. We can use the some of the services. So modern operating system and processors permit multiple processes to run simultaneously. If there is no protection mechanism in a process, all instructions from different processes will access the hardware directly and cause a system. Cause there may be problem will occur in all processes are using the same hardware. So you have to create the virtual hardware. So then all processes have must at least two modes, user mode and supervisor mode, to ensure control and access of critical hardware. Okay. So here instructions running in supervisor mode are called privileged instructions. Here instruction will be running in supervised mode is called privileged instructions. Other instructions are unprivileged instructions. Only privileged instruction only executed in the supervised mode. So other instructions are executed in unprivileged. Other instructions, it's in executed in user mode is called unprivileged instructions. Okay. So CPU virtualization. So CPU virtualization is nothing but how the process will be virtually used by more than one applications. Okay. A virtual machine is a duplicate of an existing computer system in which a majority of the virtual machine instructions are executed on the host process in the native mode. The unprivileged instructions of virtual machines can directly on the host machine of higher efficiency. So unprivileged instructions are executed in user mode only. So directly use the CPU. And then critical instructions are divided into three categories. One is a privileged instruction, and then control sensitive instruction, and behavior sensitive instructions. Here these three instructions are executed in the supervisor mode. Okay. So privileged instructions execute in privileged mode and will be trapped if executed outside the there is a supervisor mode. Okay. Control sensitive instruction attempt to change the configuration of resources used. Supervisor mode, if you want to execute the control sensitive instruction means you have to change some configuration in the ghost machine. Okay. So another one, behavior sensitive instructions have different behaviors depending on the configuration of resources, including the load and store operations over the virtual memory. Okay. So CPU architecture is virtualizable if it supports the ability to run the virtual machine privileged or unprivileged instructions in the CPU user mode while virtual machine monitor runs in the supervisor mode. Okay. So disk operations, there is a CPU architectures can be naturally virtualized because all control and behavior sensitive instructions are privileged instructions. So that's the CPU virtualization. So hardware assisted virtualization. So based on the hardware product, Intel and AMD had an additional mode called privileged mode. It is used to run the privileged instructions like x86 processor. Here we have ring 0 to n number of instructions hybridizer. The operating system can still run at a ring 0 and hybridizer can run at ring 1. That's a in physical hardware itself, the hybridizer running. And the next we have host operating system should be run another in between we have hypervisor. Okay. So all the privileged and sensitive instructions are trapped in the hypervisors automatically. This technique removes the difficulty of implementing binary translation of full virtualization. It also let the operating systems run in which is without modifications. Okay. So next one, memory virtualization. How the memory will be used based on the virtualization concept. Here virtual memory and physical memory, and then guest memory. How it will be mapped and execute the operation, perform the process. Okay. So memory virtualization is similar to the virtual memory support provided by modern operating systems. In a traditional execution environment, the operating systems maintains mapping of virtual memory to machine memory using page table, which is a one stage mapping from virtual memory to machine memory. So all modem in x86 CPU include the memory management unit called memory management unit and transverse nucleoside buffer TLB to optimize the virtual memory performance. So virtual execution environment, so virtual memory virtualization involves sharing the physical system memory in RAM and dynamically allocating it to the physical memory of the virtual machines. So in this is a diagram. Here we have virtual memory and then physical memory. How it is mapped and to the machine memory. So based on that we can perform the memory virtualization. So that means a two-stage mapping process. The virtual memory and then physical memory and then physical memory to machine memory. First virtual memory to map the physical memory and then physical memory to machine memory. Okay. Then guest operation continues the control the mapping of virtual address to the physical memory address of virtual machine, and then but the guest operation cannot directly access the actual machine memory. Okay. The guest operating system in top we have guest operating system, it cannot directly access the machine memory with the help of physical virtual memory is direct access. Okay. In virtual machine monitoring systems for mapping the guest physical memory to the actual machine memory. Here we have a diagram. This is a guest virtual machine. Here virtual machine 1, virtual machine 2. Here we have virtual machine memory. Okay. Guest virtual machine memory, it cannot directly map with the machine memory. So with the help of physical address, physical virtual memory only, it map and access the machine memory. So that's all memory virtualization. And so another one is IO virtualization. So IO virtualization is nothing but managing the routing of IO request between virtual device and shared physical hardware. Okay, in guest operating systems, want to use any IO device like a keyboard, mouse, or anything. With the help of IO workstation only, it allocate the route and identify the and perform the process. There are three ways of implementing IO workstation: so full device virtualization, para virtualization, and direct IO virtualization. Full device emulation is the first approach of IO virtualization. Generally, this approach emulates well-known and real-world devices. The IO access request of the guest operators are trapped in the virtual machine monitor, which interact with the IO devices. A single hardware device can be shared by multiple virtual machines that run concurrently. However, software emulations runs much slower than the hardware emulates. Okay, and para virtualization method of IO virtualization is the typically used in Gen hypervisor. It is known as the split driver model, consisting of front-end driver and back-end driver. Okay, and then front-end driver running in domain U and back-end driver running in domain 0. They interact with each other via block of shared memory. Okay, the front-end driver manages the IO request of the guest operating systems, and backend driver responsible for managing the real IO device in the multiplexing of host operating system. So IO and data different virtual machines. Okay. So in para IO version achieves the better device performance and then full device emulation. It comes with the higher CPU overhead. So direct IO version the virtual machine access the device directly. It can achieve close to native performance without high CPU cost. So another way to help IO is to self-specified IO. That is the key idea of self-specified harness the rich resources of a multi-core processor. All tasks associated with virtualizing an IO device are encapsulated in SPIO. Okay, so self-virtualized IO device. Okay, here we have the diagram. In top we have guest operating systems, and then it is a front-end driver, and then here you have back-end driver. So this is a virtualization layer. It performs the emulates the virtual device and remaps guest and real IO address, multiplex and device the physical devices, and then IO features, and then real devices may be different from virtual devices. So here we have this is virtualization layer. So it only can perform the operations. This is backend driver. This is front end driver. If I guest operating system want to use any device in the ghost operation system directly it allocate the routing and find the location of the ghost operating system. So in front end device driver and then back end device driver. So these two are based on the routing of IO devices. So guest device driver another one is it perform the device emulation process and then IO stack and then device driver. This is a back end driver. This is front end driver. So based on that we perform the IO device virtualization. So virtualization in multi-core architectures. So multi-core processor. Okay, virtualizing a multi-core processor is relatively more complicated than virtualizing a unicore processor. So multi-core virtualization has raised some new challenges like computer architect, compiler constructs, system designer, and application programs. There are mainly two difficulties. So application programs must be parallelized to use all cores fully, and the software must explicitly assign tasks to the cores, which is a very complex problem. The first challenges new programming model, languages and libraries are needed to make parallel programming easier. The second challenge has spawned research involving scheduling algorithm and resource management policies. So how based on this multi-core processor, so it is somewhat difficult to allocate the process to the particular applications or process. Okay, so thank you. It's about the virtualization. Okay, thank you.